Okie dokie. Sig fig. Significant figure notes. So what are significant figures? They are just numbers, that show accuracy. Accuracy about how accurate a number is. For example, if we put something on a scale and oh, this is so bad. Okay, a scale, right? And we put something on it to weigh it. And our scale says that it weighs 4.00 grams. You wouldn't write down on your paper, well, it weighs 4 grams. It does weigh 4 grams, but these two zeros, they are significant. They show that we actually weighed it and we got 4.00 grams. And so our number is more accurate and precise. So significant figures are important. Just it shows how accurate and precise our numbers are. So what do we, in chemistry, what do we always round our answer to at the end of the problem? Well, we're going to use the number that has the least amount of significant figures. For example, you walk over to the scale and you weigh out 4.00 grams of calcium, because that's how good you are. You got it to 0.00 grams of calcium. And your friend, you're trying to save time, she or he walks over to another scale and he weighs out 2.0 grams of calcium. And you go back and you put it in your container, and you now have 6.0 grams of calcium. You're not going to have 6.00 grams because even though you were pretty accurate over here, our answer in chemistry is only as good as our least accurate placeholder, our least accurate number of digits. So the rules for counting significant figures is that, first of all, everyone who has an integer, like a whole number 1 through 10, is going to be significant. And then we're only going to count zeros that are what we call like in the value or in the number. Oops. So I can show you a little trick here for counting significant figures. This is my very bad drawing in the United States of America. All right, so on the left side here is the Pacific Ocean, and on the right side here is the Atlantic Ocean. And the best way for me to show you this is to do a couple of examples. We're going to use these numbers right here, 240 and 0.002. Okay, so in my number, that is 1,240. If I look at this number and is the decimal point present or is the decimal point absent? Well, this number, the decimal point is absent. So I'm going to go this way and I'm going to go through all of the zeros until I hit a number. And I missed that 10 there. So in my number 1,240, I have 3 significant figures. All right, let me try this again with 0.002. And now in this number, the decimal point is present, so I'm going to go this way all through the zeros until I hit an integer, or a number 1 through 10. And in that case, I stop right here. So this number has 2 significant figures. Okay, so how do we round significant figures? And let's just say I have a number that is 4,260, and I want to show this number in only one significant figure. Then I'm going to go to the highest digit or the highest placeholder value, and I'm going to look directly to the right of that number. And we use normal rounding rules. If that number is greater than 5, then we round up, and if it's less than 5, we round down. So if I round 4,260 to one significant figure, I'm going to get 4,000. Okay? And if I've got a number that is, I don't know, let's say 120, and I want to round it to 2 significant figures, it actually already is at 2 significant figures. So remember, this is the Atlantic, it's absent, so we're going this way, and technically 120 is already rounded to 2 significant figures. Okay, so real quick here on number 7 and 8, let's just say we want to know how many seconds are in 52 hours. Well, I'm going to take 52 hours, and I'm using a little dimensional analysis here. In 1 hour, I have 60 minutes, and in 1 minute, I have 60 seconds. Okay, so I multiply that all the way across. Hours cancel out, minutes cancel out. I get 1, 2, 3, 2, 0, 0, 0 seconds. Okay, now I'm looking at this one right here. It says how many seconds are in 52.00. Well, the decimal is present, so I'm going this way. That lets me know that I stop as soon as I hit an integer, and there are 4 significant figures. So 1, 2, 3, 4. I want 4 significant figures. I look to the right, and that number is less than 5, so we're just going to take that to a 0. So there are 11, 2, 3, 0, 0, 0, 0 seconds in 52.00 hours. In 52.0 hours, this is only 3 significant figures, so I'm going to stop right here, and I look to the right. I'm not going to round that up because that's a 3. So there's 11, 2, 0, 0, 0, 0, 0 seconds. So this is just a simple example about how we use significant figures. This number is only as accurate as the original value that we used. Or should I say, like, the measured value. Alrighty, and I'm just continuing on. How many seconds are in 52 hours? Well, that's only 2 significant figures. So let me use those 2. Look to the right, and I don't use rounding rules there. Or I'm not rounding up, because it's a 2. So this is 11. Oops. Sorry, I'm pulling down some menu options there. 11. Oh, that's bad. You get the idea. 0, 0, 0, 0, 0, 0. Okay. Now, how many seconds are there in 50 hours? Ooh, that's tricky. Okay, so the decimal is absent, so we're on this side, and we are going that way, and we don't count that 0. So in 50 hours, there are only 1 significant figure. So I look at this guy, and I look to the right, and we're not going to round that. So that is actually 10 million seconds. So when you look on your practice sheet, now at this point you're going to go down and you're just going to do some problems, and I sent these to you in random order using the present, absent decimal. So in our first number right here, I'll just do 2 examples here with you. This one is present, right? So we're going to go from the Pacific side and go that way. And we hit an integer, so that's 1, 2, 3, 4, 5, 6, so there are 6 significant figures there. In number 2, the decimal is absent, so we're going this way from the Atlantic side, and we go all the way through those zeros, and we finally hit an integer right there, so there are 2 significant figures there. Alrighty, and that's it for significant figures.